So again, what we have here is an optimization question in calculus. And it's asking us, a normal window has a shape of a rectangle with a semicircle on top. Let me see the diagram, and I know how to draw the diagram this time here. If the perimeter of the window is 30 feet, find the dimensions of the window with the greatest possible area. Round your answers to 1 decimal place. So if we have a Norman window here, and it's asking us, a Norman window has a shape of a rectangle. There's a rectangle here with a semicircle on top here. And if I have here the perimeter here equals, so P here equals 30 feet. And it says find the dimensions of the window with the greatest possible area. So I'm going to assume that this here is my X value. This here is my Y value. And again, this guy here, or let me redraw this. This guy here is actually a dashed line, right? Because again, normal window, this isn't like a straight cut here. It's simply just a semicircle on top. And this here, I'm going to call this between this point to this point here. This is going to be my radius, so my R here. So I need to find some type of formula to figure out first the perimeter and to figure out the dimensions. Right? So I have to use this concept of area and perimeter to figure out what the dimensions of this are. So if I want to do that, let's do perimeter first. So P here would equal, I have 30 feet, so I can set this to 30 feet here. So let me just set this already to 30 feet. Equals perimeter of basically it would equal 2 parts, right? I have a perimeter, I need the perimeter of my rectangle part and the perimeter of my semicircle here. So if I have 30 equals perimeter of my rectangle, what is the formula? Well, I know it's 2 times length times width, right? Or X times Y here. So this here is my perimeter of my rectangle plus what is the perimeter of my semicircle? So this is where it gets tricky, right? So pretend I have a semicircle here. I have here, or let me pretend I have a full circle actually. Full circle might be a lot easier. This is just a side note here. But in a circle, if I want to find the perimeter of the circle, it's simply the same thing as saying the circumference of a circle. And circumference of a circle, I know here is 2 pi r, right? The circumference of a circle, or you can say it's pi d, right? But we want things in terms of radius, so I'm going to use 2 pi r as our formula here. So 2 pi r equals circumference. Well, if I have semicircle, if I split this in half, what is my circumference then? So obviously my circumference is halved, right? So which equals simply just pi r, right? So which means therefore my semicircle here equals simply just pi r. So you can say here this equals pi times r. I'm going to erase this just to make some room here. But now we have to think about, okay, we have a lot of variables here with X, Y, and we have R, right? Well, we have to think about, is there a relationship between X, Y, and R? And there is, right? If you think about this, this problem here, the distance between here to here, here to here is simply just half, right? If I have half the length, right? If I have, again, this normal window here, from here to here, is simply just half the distance between from here to here, right? And this might be better illustrated if I were to kind of download this image here. So just give me a second. I can download this image for you. And you can see that this R here is, again, you have 2R here. So you have 2R. I used X here, but R here is half this value, right? This radius is half the value of this this length here. So I'm going to assume that this here, this R, I can change this into half of X, right? This is simply just half of X. So that means I can change my R here to become half of X, right? Or I can say, I can actually rewrite this as half pi times X here. And now we have a solution here that is a bit more credible, right? A solution here that only has two unknowns here. So if I were to simplify this out, I would have 30 equals, I can multiply 2 with distributive property, so 2x plus 2y plus half pi x here. And this here is our first kind of our first perimeter basically formula here. And what I could do with these guys is I can actually isolate for, I'm going to isolate for y. And why I'm going to do that is because I'm going to create another formula for area, and we're going to actually have to optimize the area, because again, I care about finding the dimensions of the window with the greatest possible area, right? And again, with the area, I'm going to have two unknowns as well. So therefore, I'm going to require a substitution for me to get rid of a variable. So I'm going to simply do that step now. So I have 30, I'm going to bring 2x to the other side here. So I'm subtracting 2x from both sides, plus half pi x. I'm going to, again, bring half pi x to the other side as well. So I have 30 minus 2x minus half pi x equals 2y. And then I can simply divide everything by 2 here, right? If I divide everything by 2 here, y would equal 30 minus 2x minus half pi x divided by 2 here. And this here would be my algebraic expression for y. And you can kind of simplify this as well. You can say 30 divided by 2 here is 15. Negative 2 divided by 2 here is negative 1, so simply just negative x. And negative half divided by 2 here would be negative 1/4, right? So I'm just simply putting 1/4 pi times x here. So this here is my simplified form of our y here. So this here is an important equation, and we'll come back to this as well. So we've isolated for y here. Now we have to figure out a formula for x, or for area, right? Because that's what we care about, the dimensions with the greatest possible area. So area. So we want area of the total shape, right? So if we want to calculate area of the total shape, again, I have this Norman window here. I have a rectangle and a semicircle. So I care about the area of the rectangle plus the area of the semicircle, right? So area of the rectangle plus the area of a semicircle. And this is, you can say it's area total or total area. But area of rectangle, I know it's length times width. So it's basically just x times y plus area of a semicircle. So again, this here gets a little bit tricky. What is area of a semicircle? So again, if I were to draw out a circle here, this is again, this is not a semicircle, but it's just a full circle here. The area of a circle is pi r squared, right? So therefore, if I cut this in half, what is the area of a semicircle? Well, area is just simply just half, right? So this would be half pi r squared. So the area of a semicircle here is half pi r squared. So right here, half pi r squared. And then I know my relationship between x and r, right? X and r here. So r here, I know that it is half of x, right? As you can see, it's half of x here. So I can input simply, this guy here would be half of x squared, right? I'm just simply making r here equals half of x, right? I can kind of clean this up first before I do the derivative. So a equals x times y plus half pi, half of pi, and then I have half x squared. Half x squared is simply just, I can rewrite this as half x times half x. So this here is simply just half pi. Half x times half x is 1/4 x squared, right? Half times half is 1/4. X times x is x squared. And then I can clean this up by saying x times y plus half times a quarter here is 1/8, and then pi x squared. So this here is my area formula. As you can see, I have two variables here, and what I'm going to do is I'm going to do a substitution, right? I have my y here already. I'm going to substitute my y in for this y, so I have everything in terms of x here. So let me just do a substitution. So I'm going to say here sub y equal substitute y for y here. So I'm going to say here a here equals x times y here, which is this 15 minus x minus 1/4 pi. So 15 minus x minus 1/4 pi x. And then I'm going to add it plus 1/8 pi x squared. And I can clean this up here by using distributive property. Again, x times 15 here is 15x. X times negative x is negative x squared. And then simply this here would be 1/4 pi x squared plus 1/8 pi x squared. I can take now my these two terms are very similar, so I'm going to combine those terms as well. I have 15x minus x squared, and then I have minus 1/4 plus 1/8, right? So minus 1/4 plus 1/8 would be negative 1/8, right? So again, you can think of it as negative 2/8 plus 1/8 here is negative 1/8 pi x squared. So this here now becomes very, 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 very easy, right? I have this kind of a quadratic equation here. What I can do here is I can take the derivative, right? If I want to take the derivative and I want to set it to 0 to basically care about the maximum, right? So I have a prime here. This will equal, take the derivative of this guy here, 15x becomes 15, minus, I bring the 2 down here, so it's simply just 2x, minus, I bring the 2 down here, 2 times 1/8 here is 1/4 pi times x here. I'm going to set this to 0 to figure out my the maximum here, right? So set this to 0 here to figure out what x is. 15 minus 2x minus 1/4 pi x. I bring 15 to the other side, which makes it negative 15 equals negative 2x minus 1/4 pi x. And then here, I could break this down to, I could basically combine these two terms here. So 15 here equals negative 2x. Or I could factor out the x here, actually. Let me factor out the x first. I'll factor out the x here. I get negative 2 minus 1/4 pi, or I can say it's pi over 4, right? Or pi over 4 here. And then I simply have to divide both sides by negative 2 minus pi over 4 to get x, right? So x here would equal negative 15 all over negative 2 minus pi over 4. And you could plug this into your calculator if you wanted to, and you would get something like, you should get a value that looks like, let me make sure I'm in degrees here, 5.38 here. So this here, x here would be 5.38, or you can round this to 5.4, right? I want it to be one decimal place here. So 5.4, that's my x value here. And what I can do, once I have my x value, I can easily solve for my y value here using basically any of these equations here. So I would use, again, this equation here. So if x here equals, I'm going to take more decimal places here, and then I'll round as as the final answer here. But I'm going to rewrite this y equation here to give me some more real estate here. So y there we go. Y here equals 15 minus x minus 1/4 pi times x. Well, I know that y here equals 15 minus x here is 5.385 minus 1/4 pi times 5.385. You can simply throw this all into your calculator and you would get an answer of, let me just type this out, 15 minus 5.385 minus 1/4 times pi times 5.385. This here would equal 5.385. 386 technically. So this here would equal, y here would equal this number here. And this number makes sense, right? So again, but both my, my dimensions here are x here is 5.4 and my y here is also 5.4. So I can say that dimensions of window to maximize area are, and I can say it's 5 by 5, 5.4 by 5.4 feet. And this is in feet, sorry. Feet by 5.4 feet. And this makes sense, right? If I want to maximize the area, obviously, my length and width have to be very, very similar, right? Because again, the maximum area of a rectangle would be a square, right? So this here makes sense. So this here is my solution for this problem. And again, I think they have an incomplete solution here. So I'm going to write here just incomplete solution. And I'm going to see if I can type this out. So basically I'm setting, or maybe I won't show, I don't know if I can show my work, or I can take a screenshot maybe and maybe upload this, but I don't think I can. So maybe I'll just do, it looks very daunting, but it really isn't. We basically need to find formula for perimeter of shape. So this here would P equals 2 times x plus y plus half times pi times x here. And then find formula for, and then I'm going to basically say rearrange for y. So therefore y here equals, I have 15 minus x minus 0.25 pi x. And then I'm going to say find formula for area of shape. So a here would have been x times y plus 1 over 8th pi x squared. And then find the derivative, or substitute, sorry, I'm going to substitute y into area equation. So a would now equal 15x minus x squared minus 1/8 pi x squared, and then find derivative of area equation. So this here would be a prime equals 15 minus 2x minus 1/4 pi x. I'm going to set derivative to 0 and solve for x. So I have basically 0 equals 15 minus 2x minus 1/4 pi x. Therefore, x would equal 5.4. Substitute x value into y equation to solve for y. Y would also be 5.4. Therefore, dimensions of the shape to maximize area would be 5.4 feet by 5.4 feet. So this solution is incorrect because this is an incomplete solution.